Hi, everyone. It's nice to be here. Thanks for taking the time. I'm not used to having podiums in front of me. I'm used to walking and teaching at university classrooms, so this is a little unusual, so I'll step away from this. So I'm going to talk to you about some use cases in AI, but to do that, I want to ground some sort of common thinking about the evolution of technology. So if you've ever taken a technology strategy course or tried to understand the foundation of the evolution of technology, you've probably heard of something called an S-curve. Can I get a show of hands? How many of you have heard of something called an S-curve? Yeah, maybe half? Okay, so let me briefly describe it. Imagine, I don't have slides here, so imagine you have a graph with the y-axis being some performance parameter and the x-axis being time. So now we can look at any phenomenon with improvement of performance over time. So it's a dynamic evaluation of performance. So let's take sailing ships that continue to gain speed. If we were measuring speed capacity effectively on the y-axis, a sailing ship can go as fast as the wind can take it and the design of the sail, but it's limited by the physics of how fast wind can create the force that's necessary to sort of move the ship, right? So think of it this way, I'm going to do this backwards. You can have over time, you can have speed increase, but it has some sort of asymptotic limit, right? It's going to be limited by the physics of the sail being able to capture the wind and move the ship. Similarly, you can apply that concept to modern technologies. Let's take your precursors to storage on a laptop would have been a hard disk drive. So for the modern generations, you're only used to what's called NAND flash or solid state drives. Prior to that, we had electromechanical moving disks, hard disk drives that would rotate at like 7,200 RPM. That was actually considered fast. And they would store data, but it was an electromechanical moving part. So it's again limited by physics. And so you could store megabytes or gigabytes or terabytes of data, and the performance was continuing to increase because of Moore's law, which many of you have probably heard of, right? We're improving the performance by almost 2x while reducing the cost in half, typically over approximately 18 months. So you're continuing to see the performance, the amount of storage per volume of disk continue to improve on a hard disk drive. And then you see an asymptotic limit. And essentially, the only way you break that is a new S-curve. You have some foundational technology that fundamentally changes that. In this case, it was NAND flash. There's actually NOR flash and NAND flash was a standard that took off, increasing the density of storage while reducing the cost. That's how you can boot the kernel of your operating system so quickly on your phone or on your laptop or other types of computing technology. So the same thing has happened with AI, but AI is more fundamental. We fundamentally changed our ability to develop technologies systemically across everything you can imagine, from the example of a sailing ship to the amount of digital storage you can have on a medium like NAND flash. What's interesting is that AI is going to potentially accelerate Moore's law, but the cost of compute hasn't been figured out yet. It's very expensive to run all of this AI, and that hasn't been amortized across the cost of the distribution of the innovations coming out of AI. So we're still figuring this out. This process is really messy. And the implications for society, I think we've already sort of echoed, are huge. What I'd like to do is give you a couple of those examples, things that you may not see in your daily life that I'm involved in. So I know most of you want to hear about things like dating and Tinder, but we're going to maybe come back to that. Why don't we talk about things that have a little bit greater impact on the relevance of our lives in ways that are more meaningful. There's a company I'm involved in called Synaptica Therapeutics. Synaptica is trying to address one of the diseases of our decade, which is Alzheimer's. How many of you, raise your hands, have a family member or a friend or know somebody that's been affected by Alzheimer's or dementia? Almost every hand in the room. There's just a few hands not showing. This is a disease that robs you of who you are as a human being. And it doesn't just rob you, it robs the people around you. So it destroys families, it destroys livelihoods. I mean, if you start to simplify what we are as a human being, and I'm not talking at an esoteric level, I'm talking at a practical level, it's really the experiences and the collection of the memories that we have. And if those memories are stolen, you have to ask yourself, what are you at that point? So I call it sort of the disease of our decade, because although there are terrible diseases that exist, the prevalence of cancer and heart disease and other things that affect our human condition, really only Alzheimer's and the impacts of dementia, rob you of who you are as a human being in the declining process of that disease state. Most of the medical solutions that have been emerging for Alzheimer's have been pills. Pharmaceutical company likes to produce pills. They're good at manufacturing pills. The side effects can be tremendously difficult, and the efficacy for the rate of declination of your deterioration of the brain is sort of limited. The efficacy of the first drug that was approved very recently in the United States was hovering around 30%. And for women, the efficacy was about 12%, and the side effects were very high. In fact, a lot of physicians just wouldn't prescribe it because the downsides were much worse than the potential benefit. And then there was another drug approved recently with very similar order of magnitude efficacy. Again, about 1 out of 3 people, if you're lucky, would actually see some benefit of halting the decline, and then at the same time would experience massive side effects. So again, the disease of our decade, over decades, we have made very little progress toward addressing this. But instead of taking a pharmaceutical biotech conventional approach, there's a company that was doing research out of Harvard Medical School and faculty in Rome, and they came together to publish research on the use of neuromodulation, essentially neurostimulation of the brain, in very specific ways that would be controlled by AI, essentially machine learning, understanding feedback loops in the brain, specifically in the default mode network of the brain. And the research that they published, which has been published in Brain and a number of other prominent journals, resulted in 82% efficacy in halting the gold standard markers for Alzheimer's, across all the gold standard markers with neurostimulation. So this is not evasive. You're not ingesting something that could have a lot of side effects. You're going in for a treatment, and then you go in for regular treatments to address what is really, in some cases, a chronic disease, without all of the side effects, at a fraction of the cost, with dramatically better efficacy. You could only do this because AI has unlocked the power of taking technologies that were well understood. Neurostimulation and neuromodulation has been around for decades, but applying that in a clever way to the right place in the brain, making sure you have the feedback loops to monitor the efficacy. That is remarkable. So you're taking an existing S-curve and essentially creating a new S-curve out of it to have dramatically improved performance over time because you applied AI. That's the type of opportunities that we have in front of us with the implications of AI broadly in society, and it's not just about creating better matches in a dating service. Let me give you another example. This is another company that I'm involved with. I helped co-found a few years back called Monet Analytics. In Monet, we decode human emotion. We use machine learning, deep learning, and AI to understand when someone has nonverbal cues, what is it about their facial expressions that tells you their emotional state. Now you can imagine the simple use cases for this, right? You could imagine conducting focus groups and really understanding what people think. You could look at a movie studio that's going to release a film, and they're going to spend $100 million making a film, and they need to know and predict before they release it, is this going to be successful or not? And there's an outcome where this is going to be a $1 billion film. Can they read the audience and say, yeah, it's going to be successful, or no, we need to change the plot or change some of the takes we took to improve it? So there's pure financial considerations for improving the performance of any given circumstance where you could decode human emotion, right? But that stuff is sort of less interesting. I think it becomes really interesting when you talk about other epidemics happening in society, the diseases of loneliness that's really impacted our society, modern society today. Could you have a digital companion that could talk to you, that you know is digital? You're not trying to fall in love or find companionship in the real world, but just have someone to talk to that understands who you are, that's learning from who you are, that's there when you need them most. Other implications for decoding human emotion are quite interesting. It would be a natural lie detector, right? You could detect potentially deception. That would be fascinating. You could apply that to a debate that we just saw on TV. There's another company that's focused specifically on deception. It's called Data and Truth Analysis, another company I'm involved in. They have longitudinal research that they put into the commercial space to detect deception. So imagine you have large corporations putting out earnings releases, and they're massaging how they talk about something to sort of paint it in a positive light, but there's really deception there. This technology has been used to go back and look at the statements made with companies like Enron or FTX and you can detect a high level of deception. For my own venture capital fund, I actually ran my quarterly report through the technology, through Data's technology, and I came out with 99% efficacy, which is like essentially the top level of non-deception that we don't, we're communicating very directly. So the types of technologies that can be improved and can unlock new use cases with AI are remarkable. I could imagine a decade from now, every company in the world goes through a hygiene process where they check their statements and make sure there's nothing deceptive in there, right? You could start to even look at predictive accounting fraud based on using these types of technologies and eliminate these types of incredible, catastrophic company shutdowns because of deception. That's a big deal. You can stop that sort of existential risk. So the implications of AI, I've just given you a few examples, are so broad and they're so remarkable. They fundamentally change how society functions. We have so many grand challenges on Earth that we have to address. I don't want to list all of them out, but obviously for many of you, you're probably familiar with the challenge we have with climate change. So I left my previous fund to go back to get a PhD at Stanford in the engineering school focused on addressing climate change at a systemic level. And the types of problems and the grand challenges we have on Earth are not always well suited to be solved within the construct of capitalism. Things that have exhibit problems like free rider problems or tragedy of the commons problems. These sort of attributes are very difficult to solve for capitalism. That's not really what capitalism was well designed for. But capitalism is the only system we have. And I'm a capitalist and I believe in it. But for certain types of problems, if you had to do a system design, you wouldn't design it that way. But AI unlocks the possibilities to solve some of these problems because it almost serves like a technological intervention to advance capabilities to create system design to address these types of very difficult problems. So I guess what I'd leave you with is to think about the implications of AI in your daily life and not think about AI as just a tool, but rather ask yourself questions about how data would get trained using my data, and Ed already referred to this, but is it actually giving me the right guidance and recommendations? Because their training data had to be applied in order for that AI to be able to do the magic that it does. And the quality of data exhibits a high degree of variance. And so if you train the wrong data and you have the wrong recursive learning models, you could actually end up with something really dangerous, right? So the guardrails around this require humans because we're the ones developing the AI. So as you're working in your companies and as you're applying AI, think about the guardrails and think about the operating manifesto and essentially the ethics that serve as a guardrail for how this AI would get used in your daily life. But if you're involved in your companies and actually projects that develop this, think very carefully about the design because we all know what the potential impact is for the abuse of technologies. We've seen how social media can polarize society. There's so many infinite examples of the abuse of technology. We don't want to go down that road on the artificial intelligence front. So we, as actors in this play, all play a role in shaping what that looks like. So you have to really think deeply about your interaction with the AI and in the use of the training data, how it trains the AI on the projects that you're involved in. With that last thought, I guess I'll just say that do you think the goal is to use great training data to train AI? Is that the goal of all of this? I might argue that the goal is not to apply training data to train great AI. It's for the AI to augment and help and improve the human condition. That's the ultimate goal. The other comment is really the input into that process. And based on how society's going, maybe it's not to improve the human condition, but it's to improve the sentient condition. Because I do think AI is going to have some level of consciousness as we see a society evolve. First, it depends on how you define consciousness. I'm not saying that AI will develop consciousness, but there's certainly a risk that it can act on its own. And how we define consciousness then determines whether something is sentient or not. So maybe we're splitting hairs on the semantics, but it's very conceivable to me that based on the definition, we could have a self-aware AI. That's a real concern. And that's been going on for quite some time. This is not something new, and you didn't even need AI to do that. This was the foundation of automation. So the question is, are we making a trade-off with the human condition, with the efficiency we're getting from AI, or I'm broadening that question to automation? If you were to walk into Newark Airport, which is right here outside of New York, and even a decade ago you were ordering food, you were doing it on an iPad tablet instead of maybe interacting with a human. If you were in San Francisco Airport, I'm just picking airports because I spend a lot of time in airports. If you were at SFO, there's a kiosk where you can just get a coffee made by a digital arm, which is an automated piece of technology that's producing your coffee because they're repetitive tasks. We're seeing this with pizza making. We're seeing this in cloud kitchens. You can go down the list, and I'm picking food because it's an easy, tangible example to talk about. But where you see a lot of interaction in the human condition is with customer service and engagement in products and services where we interact with other people. And I absolutely think there is a trade-off between the human experience of engaging with one another and technology serving that purpose, potentially more efficiently. And if you amortize the cost of the capex of that technology far more cost effectively over every interaction, depending on your unit, your basis for your unit analysis. So we are getting efficiencies and productivity gains, but we are losing some of that serendipity of the human interaction. And you could say it's contrived, but this is happening slowly, so we get used to it. If it would be jarring if we were thrown into it, sort of like a frog put in cold water where you slowly turn the temperature up versus throwing it into boiling water, it would jump out. Similar analogy maybe for how society is coping or dealing with some of these changes. They're happening slowly so we get comfortable with them. But I don't think that's necessarily a terrible thing. We find offsets to find the social and humanity in our engagements in other ways. And it does free up time to unlock other experiences. It's just a matter of whether we take advantage of it.